Hello ladies and gentlemen, and welcome to lesson 4.4, the sine law. Now, this is different than the sine ratio. We have to be very, very clear about that. The sine ratio dealt with a right triangle. It had to be a right triangle. It would have a hypotenuse. It would have a particular angle we were talking about. And from that angle, we have an opposite side and an adjacent side. And the sine ratio said that the sine of this angle was equal to the length of the opposite side over the hypotenuse side. And that is your sine ratio. That is not the sine law. The sine law is different. First of all, it doesn't have to be a right triangle anymore. It can be any old triangle. So it could be a triangle that perhaps looks more like this. And what the sine law says is it says that there is a relationship between each of the angles, the interior angles, and the side lengths of any triangle. If I call this side B, if I call this side little c, and I call this side little a, the sine law says that the following ratio will always be true. If I take this angle, sine of a, and if I divide it by the length of the side opposite it, that will be equal to any of the other angles. The sine of the other angles divided by the side opposite that angle, which also will be equal to the third one over top of the side opposite it. All three of these will always be equal. In other words, this pattern of sine of an angle divided by the side length opposite it will always equal the sine of any other angle divided by the side opposite it. And if that's true, we can also go the other way. We can say that the side length divided by the sine of the angle will be equal to, see what I did there? That has to be B because I did side B. So then it would be equal to side length A over sine A, because side A, angle A. And then side length C over sine C. So it doesn't matter which way we go. The idea is that the sine of the angle divided by the side length will equal the same for any of the angles and sides of any triangle. So this is the way you're going to see it. And I don't suggest that you memorize. I suggest that you always be able to work with just the concept that a side length divided by the sine of the angle will equal a side length divided by the sine of an angle. Or, alternately, the sine of an angle divided by its side length will equal the sine of an angle divided by its side length. Okay, so where do we use this? We use it, the sine law can be used to solve any triangle except for those using an obtuse angle when given either of the following: the measure of two angles and a side, and the measures of two sides and an angle opposite one of those sides. Let's not worry about memorizing that. Let's do some examples and we'll see when we can use it and when we can't use it. Now this is an interesting little caveat here. Them saying a caveat means that it's just an extra rule, a special case where it's not going to exist. So it says that it's going to work anytime that we work with a triangle that does not have us solving for an obtuse angle. An obtuse angle is an angle that's going to be greater than 90 degrees. So it's going to work for any triangle that looks like this. Okay, so as long as this is going to be less than 90, okay, it's going to work. These are definitely less than 90, but when we get into something that might be larger than 90, we shouldn't be using the sine law. There's a reason for that. It'll give us two answers And what we'll use is a different law whenever we're going after an obtuse angle. We'll use what's called the cosine law, and that'll come up in our next lesson that we do. So there's a little caveat there. We have to be careful. We don't want to use the sine law when we're solving for an angle greater than 90. If we do, then we're going to get into a situation that's called the ambiguous case of the sine law, and it makes things tricky. Okay, so looking here, I have a triangle, and it's not a right triangle. I know that because I know that that's 63, that's 74. This is going to have to be less than 90. The interior angles of any triangle have to add up to 180. So this angle here, if I want to do a little bit of work, step 1, I can say angle P is going to be 180 degrees minus 74 degrees minus 63 degrees, and I'm going to come up with 180 minus 74 equals minus 63 equals angle P is equal to 43 degrees. So we have an angle here that is less than 90 degrees. That means that we can use the sine law. Is it appropriate? Let's see. If I want to come up with this side length, I know the angle opposite it. I also know this side length and the angle opposite it. So in fact, I didn't need to find 43. I'm not using 43 in this one because I don't know this side length. So let me be clear about that. I'm after this side length. So this side divided by the sine of the angle opposite it. So Q will equal sine of 63. I also know that that must equal 12.7 over sine of 74. And I also know that if I make this a little p, how am I going to distinguish that as a little p? Maybe I'll put a little tail on it there. That's supposed to equal of sine of the angle opposite it. This one over that. Now, I have three things. This is the sine ratio, the sine law. This is what the sine law says. But the truth be known, I want Q. I don't need to know anything about P. I didn't need to know 43. I can determine Q with just those two. I didn't have to do this work up here. It doesn't hurt that I did it, but I don't have to. So when I go after Q now, I really need to worry about sine of 63 equals 12.7 over sine of 74. Now in the work that we've done previously, we know that this is a decimal. This is a decimal. So I'm going to multiply both sides by sine of 63. I'm going to show it once, and I'm not going to do it again, just because it's a little bit redundant. So I'm multiplying both sides by sine of 63. What that allows me to do is, because this is over top of 1, I have sine of 63 times Q divided by sine of 63. They're going to reduce. And top times top, bottom times bottom, I'm going to be left with Q equals sine of 63, 12.7 over top of sine of 74. Using your calculator, make sure you're in degrees. So 63 sine times 12.7 equals, divided by 74 sine equals. Now hold on a second. Let's make sure you guys can do that. It says to the nearest tenth of a centimeter, so that's 1 decimal place. So that'll be 11.8 centimeters. Now again, let's go back and make sure you can do this. So what did I do with my calculator? I did 63 sine. Some of your calculators will require you to hit the sine first, then 63 and equals. I then multiplied it by 12.7 and I hit equals. Then I need to divide it by 74 sine. Now that is the decimal of 74 sine. I need to hit equals so that it divided what I had on top by that. And I get 11.8. So there you go. That's how we do those questions. And I will stop here and come back with the next one.